This is May 2009, paper 2, time zone 2, question 8. And it's a question about permutations and combinations and the number of ways people can sit at a table. Now, there are loads of ways to answer this question, and there's even 2 ways to interpret it. Whether you think all 6 positions of the table are distinct, or whether you think person A, B, C, D, and F sitting next to each other is the same combination, whether A is sat nearest the window or nearest the door. Where it doesn't matter where A is sat and where B is sat, as long as they're in the same order. I'm going to interpret it as if the chairs are distinguishable, and you can tell the difference between the 6 positions that we might sit. But at the end, I will point out how you can easily convert between one and the other. So, in this interpretation, if there was no restrictions about where people could sit, then it would just be a case of 6 factorial options, which is 720. Because the first person has a choice of 6 seats that they can sit in, the next person has a choice of 5, the next a choice of 4, then a choice of 3, then 2, then 1. It's not my best presentation skills. Which is 6 factorial, which is 720. We have got restrictions. So some combinations are forbidden. In particular, there's 2 people, person A and person B, that can't sit next to each other. So let's imagine that A and B do sit next to each other. Well, how could that happen? Well, you could have A and B sitting in these 2 seats, or in these 2 seats, or in, let's change colour, these 2 seats, and so on. There are 6 positions for A and B to sit in that would be forbidden. Once they've chosen those 6, and within those 6 positions, probably makes more sense to this now, within those 6 positions, there's 2 orders. Because it could be AB sitting, or it could be B sitting then A. Both of those combinations would be forbidden. Okay? If we sat those 2 people first and we sat them together, there'd be 12 positions for A and B to sit together that are forbidden. Once they've sat down, there's 4 seats left. It doesn't matter where the other people sit, so that would be times 4 factorial. 4 positions for the next person, 3 for the people after that. So that's 12 times 24, which is 288 forbidden combos. So all you have to do is take our 6 factorial from before, subtract the forbidden combos, and you're left with an answer of 432. Now, I said that that's assuming that the chairs are distinguishable. If you want to interpret it the other way, there's a quick way, distinguishable. That's what that says. Kind of give up. If you want to interpret it in a way that means that the chairs aren't distinguishable, well, that means that any one position, say A, B, C, D, E, F, is the same as a position like this, with A there, B there, C there, D there, E there, and F there. If you think that the circular table has indistinguishable chairs, then every position, each way of organising people, each organisation of people, has 6 equivalencies, 6 rotations. And so how could you work that out? Well, you could say, well, the 432, when I don't care about their position, divided by 6 rotations gives me 72 combos. So depending on which way you interpret this question, gives you two different answers, 432 or 72.